So this is question 10. We are given events A, B, and C, and we are told that event A and B are independent. So when event A is independent to event B, which means when you multiply the probability of A and B, it must give you the intersection of A and B. So so this is what we are given here: probability of A and B and the intersection of A and B, and they're also given the complement, which, we're also given the probability of C because we have probability of C. So 10.1, are event A and B mutually exclusive events? So mutually exclusive events have an intersection of A and B being equal to 0. Here you really don't have to do much. You can simply say, since probability of A and B are not equal to 0. Why am I saying they're not equal to 0? There it is. We already have the intersection. There it is. Probability of A and B. If you have this, it means and in probability. If you have this, it means union. Right? So we already have the probability of A and B, and it's 0.1596. So because it's not equal to 0, therefore not mutually exclusive. Fine. So we are done with 10.1, and 10.2, by using an appropriate formula, show that the value of P of A union B is equal to 0.64. So we want to identify the union of A and B now. We already have the intersection. So for us to determine that, we're going to say the P of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. Right? So the probability of A is equal to 0.38 plus the probability of B, which is equal to 0.42, minus the probability of A and B is equal to 0.1596. So when you add everything together, you're going to get 0.6404, which approximates to 0.64. So this is the union of probability of A and B, which we've already proven. Fine. 10.3, calculate the number of people in the sample space. So now I want you to take a look at the information given. We are given the probability of A, we are given the probability of B, we are given the probability of A and B, we are given the probability of C. So to find the union, or to find the sample space which is N of S, to find the sample space of N of S, we need to know the number of the sample, the number of sample. So in this case, we're not given the number of the sample. The question doesn't have N of the sample. So because we are looking at the number of people in the sample space combined, so let's say, for example, you have your diagram. Let me draw the diagram. So let me erase this. So if you have something like this, your Venn diagram, and this is your event A, and this is your event B, and you're told that they're independent, which means they have the intersection, and then you have event C like that. So for us, we need to identify the number of, let me check the question, the number of people in the sample space. So we need to identify the number of people that exist in a total of event A, B, and C, and those that exist here. So the sample space is the entire thing here, sample space. So the formula of a sample space is written as follows. P of whatever event, let's say P of E is equals to N of E over N of S. So if, let's say, for example, we are focusing on event A, it means that we need to know the number that exists in the sample of A to be able to find the sample space. We know this. We know the probability of A, which is equal to 0.38. But we don't know N of A. We don't know N of A. The number of ways that this event happens. We don't know N of A. So it's not known. Hence, we cannot identify the number of samples. If, let's say, for example, we were told, because we are looking for this guy here, the number of samples, we would cross multiply and say N of S multiplied by P of A is equals to N of A, right? And to find N of S, we divide by P of A, meaning N of S is equals to N of A divided by P of A. So this is how we would find the sample space of this problem here. But since we don't know this problem here, we don't know the value of N of A, but we know this one, so we cannot identify the number of the sample space. It cannot be identified if this N of A is not known. So 10.4, we are asked to find N of complement C, right? So the complement of C, which is the C that we were given here. So for us to find that, we're going to do this. We already know the probability of C, right? The probability of C is given as 0.28, and P of the complement of C is going to be equals to 1 minus P of C, right? So it's going to be 1 minus 0.28. So this basically means P not C, right? So the answer you're going to get here is 0.72. So this is P of C naught, right? And so this is P naught of C. Let me write there, P naught C. Cool. So for us to find N of C naught, it's going to be equals to P of C naught multiplied by N of S. So for us to find this value here, the number of C naught, we need to also have the sample space. So already we have 0.72 for P naught of C, right? So we need to have the number of the sample space for us to complete this problem here, because in 10.3 the N of A was not given, hence we cannot identify the sample space here. So you can leave the question here, not unless there's something missing in that question which was rectified during the exam. So but this is how you go about solving this problem here. If you have any questions regarding this problem, please write down in the comment section below, or any suggestion, you are welcome to comment. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them in the comment section below. Don't forget to subscribe to the channel for more videos.